You see also here you need a flow field, and that's what this guy actually is analyzing, because there's very high pressure on this flow field, and there are different designs, but he has this meander. Here you see the stress on the membrane. So this is the flow field channel, and if there's 50 bar here and 10 bar here, then you have very much pressure difference. So this is one cell design for a single cell. So you have the end plates, maybe you have a gasket, a current collector where you put in your plus and minus. This is the flow field. You see this is the channel. So there's this gasket. Go a little bit closer to the membrane itself. Here we're talking about a zero gap membrane, they say. I wrote down we can use a lot of membranes like Nafion 212, 117. They spotted the platinum catalyst. The other one maybe just use this ink spreading technology. Here we now go very deep into the proton exchange membrane, and it's a polymer. Yeah, we see lots of carbon in a chain. That's a polymer. We can also say plastic. It's fluorinated. That is sulfuric acid. That is why your catalyst needs to be so corrosion resistant, because this is very acidic. But of course we want to see how it looks like in real life, and here you see maybe Nafion. If you watch the video about how to make the membrane, 5 tips on how to improve your hydrogen generator, then you will see that this is kind of a jelly material when it gets wet, right? So water and this, because only with the water you can have the sulfuric acid belonging together. Because of the high pressures here, they are describing external support, but additionally some meshes, very complicated meshes to support the membrane. You have this excellent picture like a non-support membrane. This is after very, very rugged support. You can put a weight on and it's kind of rigid.